Hi everyone, welcome to Mathworld. This is Cambridge International AS and A-Level Further Mathematics, Paper 2 for October-November 2022, and the code is 9231/23. Alright, so let's move on to question 1. Now, question 1, find the Maclaurin series for ln 1 plus ex up to and including the term in x squared. So, for the Maclaurin series, since it is up to x squared, means that you need to differentiate up to second derivative. So, first of all, I will let the function be fx. Okay, then after that, you have to let the x be 0 for the Maclaurin series. So, now you will be getting f0 equals to ln of 1 plus e0. So, and then we know that e0 is basically 1. So, 1 plus 1, you will get 2. So, therefore, your head f0 will be ln 2. Now, when we need to differentiate the f prime x, right? So, the formula for differentiation of the ln, so differentiate ln fx, is basically over fx, and the numerator will be f prime x. Okay, this is how we differentiate the ln fx. So, now, f prime x will be over 1 plus ex. Then when we differentiate 1, you get 0. Differentiate ex, you'll be getting fx as well. So then, followed by the value of the f prime 0. So you will get e0 over 1 plus e0, which means it will be 1 over 2. That is your f prime 0. Okay, now, next is f double prime x, because of the x squared. So now, for the f double prime x, since your f prime x is the rational function, which means when you need to differentiate, we need to apply the quotient rule. Okay, so according to quotient rule, you need to keep the denominator and square it. And then for the numerator, first term will be 1 plus ex, means that you rewrite the denominator. Then now you differentiate the numerator. So when you differentiate ex, you'll be getting back ex. And then the sign is minus, according to the quotient rule. And now you keep the ex, which is the numerator, and differentiate 1 plus ex, you'll be getting back ex. Okay, so now if you want, you can just simplify. So now it will be ex. Okay, here ex. You can just write ex. Then here left 1 plus ex. Then once you factorize the ex here, that means you still have one more ex. So minus ex over 1 plus ex squared. Right? So now, which means you'll be getting the bracket 1 plus ex minus ex over here becomes 1. So I will end up with ex over square of 1 plus ex. Right? So now your f double prime 0 will be counted based on the last form. So I will get e0 over 1 plus e0 squared, which is 1 over 2 squared. Then you'll be getting 1 over 4. This is your f double prime 0. Okay, so now the Maclaurin series. So here, Maclaurin series. So ln 1 plus ex. So according to the formula, it will be f0, which is a ln 2. Then plus f prime 0, which is a half. So here, plus half. Since this is the value after you first differentiate the function, that means you multiply by x. Then plus, the second derivative is 1 over 4, followed by x squared over 2 factorial. Okay, then now simplify, and you'll be getting the Maclaurin series. So, your Maclaurin series will be ln 2 plus half x plus, now the denominators now become 4 and 2 factorial. So, 4 times 2 factorial is basically 8. So, I will get 1 over 8 x squared. Right, this will be your Maclaurin series. Okay, so done the question 1. Alright, so now let's move on to question 2. So now question 2a, show that the system of equations, so you are given 3 equations here, where the a is a constant, does not have a unique solution. So when it does not have a unique solution, means that you need to prove the determinant. Okay, basically you need to prove the determinant is not equal to, sorry, the determinant equals to 0. Okay, you need to prove determinant equals to 0. So now for the determinant of the matrix, okay, so I will rewrite the matrix. So the coefficients of the variables will be 1, here minus 1, here is 2. So I will write 1, minus 1, 2. For the second equation, it will be 1, minus 1, and minus 3. So 1, minus 1, minus 3. Right? And then for the third row, it will be 1, minus 1, and 7. So 1, minus 1, and 7. This is minus 3. All right. Now you need to show it is having the determinant of 0. So we shouldn't write equals to 0 first. So we need to show the calculation. So now for this case, right, since this is 3 by 3 determinant, I'm going to fix the first row. So when I fix the first row, then I have to label the sign of the first row. So now I fix the first row, and then I'll consider the first column for my first step of the calculation. So now the crossout is 1, and the sign is plus. Therefore, plus 1. Then the remaining elements will be minus 1, minus 3, minus 1, and 7. Okay. Then for the second row, second column, now I fix the second column and consider the first row. The crossout is minus 1. But then the sign here is minus. So minus minus becomes plus. Therefore, I will write plus 1. Okay. Then the remaining elements will be 1, minus 3, 1, 7. Now, let's move on to the third column. So when I fix the third column, obviously the crossout is 2 right now. So now the sign for the 2 is plus. So like we have to write plus 2. Then the determinants of the remaining numbers or remaining elements, it will be 1, minus 1 in the first row and 1, minus 1 in the second row. Okay, so now I have reduced it to 2 by 2 determinant. So now we just need to use the cross multiplication. Okay, so minus 1 times 7, I get minus 7. Then minus 1 times minus 3, I will get 3. So this is how we get it. Now plus 1, then 1 times 7 is 7, minus 1 times minus 3, I will get minus 3. Then plus 2, then 1 times minus 1 is minus 1, then minus 1 times minus 1 is minus 1. So now from here, you will get minus 10, because minus 10 times 1 is still minus 10. Then the second bracket is basically plus 10. And then the last bracket here, minus 1 plus 1, it will be 0. That's why you get determinant equals to 0. So now you just write, since the equals to 0, the determinant equals to 0, which means the system of equations does not have unique solution. Okay, does not have a unique solution. All right. So you must remember, when you need to show that the system of equations does not have a unique solution, means that you need to prove that determinant equals to 0. Okay. So now, given a equals to minus 5, show that the system of equations in A is consistent. Consistent means that you will have solution. All right, it's either unique solution or infinite solution. So interpret this situation geometrically. So now, since now you are given a equals to minus 5, which means we need to replace the a value, and we are going to show this using Gaussian elimination. Okay, so now I will rewrite this system of equations in the augmented matrix form. So the augmented matrix, it will be, right? So write down the coefficients 1, minus 1, 2, and then draw a dotted line to split the answer here, the values on the right side. So I will write 4. So therefore, I will be getting 1, minus 1, 2, then 4. Okay? So you can just use a solid line instead of dotted line for the augmented matrix. So then the second equation here, it will be 1, which is here 1, minus 1, minus 3, and add on the a. A is minus 5. So I will get 1, minus 1 minus 3, 5. Then the third will be 1 minus 1, 7, and then 13. So 1 minus 1, 7, after that 13. Okay, so we need to reduce it to the epsilon matrix, right? So now, by using the row operation, so for the epsilon matrix, you need to change this 1 to 0. You need to change this to 0, this to 0, right? This will be done in the first step here. So now, to change the second row, the first element in the second row to 0, I'm changing row 2, all right? And then the operation, since it is in row 2, then we are going to involve row 2 and row 1 because this is in row 2 first column. So now I will write row 1 and row 2. All right. So the row that I'm going to change, I will always write plus. Then you can allow to times any constants for the row 1 and row 2. So now R1 is row 1 is 1. So here is 1. Therefore, I need to times a minus to the row 1 so that it becomes this 1 becomes minus 1. So minus 1 plus 1, it will be 0. Okay, that is my operation, row operation. Then now for the row 3, here, I'm going to change it, okay, to 0 as well for this one by involving the row 1 and row 3 because this one is in third row, first column, right? So row 3, row 1. And the row that I want to change always remain as plus. So again, for row 1, when you compare row 1 and row 3, both are positive 1. So I times minus to the row 1. Okay, so we rewrite the first row because we are not changing the first row. But then for the second row, so we have to recalculate all the values using this operation. So minus 1 plus 1, it will be 0. Then here, minus 1 plus minus 1. All right, plus minus 1 here, it becomes minus 2. So here, minus 1. Okay, wait. Here, minus 1. You multiply by minus. It becomes positive 1. So positive 1 plus minus 1, it becomes 0. Okay. So you really have to be careful when you calculate this. Then the third number here, so you times minus 1 minus to the 2. So when you times minus to 2, it will be minus 2. Minus 2 plus minus 3 becomes minus 5. Okay, I miss out the second term. So here minus is a plus 1. Then here plus 1 plus minus 1, it becomes 0. Okay. All right. So now for the third the 5 here after the line, the straight line. So we still need to count using minus R1 plus R2. That means it's minus 4 plus 5. I will be getting minus 4 plus 5. Okay, let me check. Wait, your A is basically minus 5. All right, so there's a mistake here. This is minus 5. So now it should be minus 4. When you multiply the minus to the first row, it will be minus 4 plus minus 5. So you'll be getting minus 9. Okay, so this is how we count the first row. Now, for the next, the R3. So the first one will be 0. Now minus R1 plus R3. So minus 1 is 1. Okay, plus minus 1, it will be 0. Now the third one, minus 2 plus 7. Here is 7. It will be 5. Then minus 4 plus 13. It will be 9. Okay, so now from here, this is not yet epsilon matrix. So from here, we need to change the third row, the 5 on the third row to 0. All right, so I'm going to change third row. So since this 5 is in third row and third column, right? So I'm going to times, all right, or probably, if you notice that these two are the same, all right? So I will just do one step first before I change the row 3. So I change the row 2 by multiplying a negative. So then I will get 1 minus 1, 2, 4. Then 0, 0, 5, 9. Then the third row, I do not change. Okay, I make it to this first. Then now, I change the third row. So, third row and second row, basically, they are the same. Therefore, I'm going to write minus R2 plus R3. Okay, because right now, this is not yet the epsilon matrix. So, I will rewrite my first two rows. But then when I use minus R2 plus R3 to recount the R3, I will get 0 because it is the same as row 2. Okay, so from here, right, we will be getting the solution. So when I form the equation, I will be getting 5z, right? 5z equals to 9. Therefore, you can get the solution here, right? And then x, because here is 1, so x, 1x minus 1 means minus y. You form that the equation, plus 2z equals to 4. Okay, here is the 4. So you replace the z value. So now, your x minus y plus 2 of 9 over 5 equals to 4, right? Then from here, I will be getting one equation in terms of two variables, x and y. So I may let y equals to t. Then I will get the x. So my x is 4 minus 2 bracket 9 over 5 plus t. Therefore, you'll be getting 2 over 5 plus t. Okay, so from here, you are getting the values for the variables, even though x and y are in terms of t. That means you are still getting consistent equations, right? So from here, you can just write the system is consistent. Is consistent. Okay, so this is how we show it. Now, interpret this situation geometrically. So how do we interpret? So now you should notice that there will be infinite solution because of the y and x in terms of t. That means the interpretation, okay, so let me use the green color. So the interpretation will be right, all planes, all three planes have common line because, or you can say, yeah, because they have the infinite solutions, right? So you can say all three planes form or have a common line, up to you, from a shift. Okay, this will be the interpretation. All right, so this is question B. So we need to perform the row operation. Now, for C, given in state A is not minus 5, all right? Show that the system of equations in part A is inconsistent. Inconsistent means that there's no solution. Okay, so now since A is not equals to 5, not equals to minus 5, which means now you have to keep this minus 5 as A. Okay, in other words, we have to redo the row operation. So I will just copy back this whole augmented matrix. So I rewrite the augmented matrix from the B. Okay, the operations here, the row operations here will be exactly the same because your A is on the right side. It will not change the operations. All right, so I'm still using R2 is minus R1 plus R2. R3 will be minus R1 plus R3. Same operation as in the part B. So first, row, just rewrite. Okay. Now, second row, basically, all the results here will be the same. All the results here will be the same, except the value after the slash. Okay, so I'm going to copy back 0, 0, minus 5. Right, so now for the last value here, instead of A, then calculate using the operation minus R1 plus R2. So it becomes minus 4 plus A. Okay, and there's no change for the R3 because R3 does not involve, when you change the R3, it does not involve the row 2. So I will copy back the answer from previous step, which is 0, 0, 5, 9. Okay, so now I will rewrite the first row because this is not yet the epsilon matrix. So for the second row, you can just rewrite. Now, third row, I need to change the 5 to 0. So which means now I refer to the row 2 and row 3. Okay, so row 3, it will be, since the row 3, the value is minus 5, sorry, row 3, the value is 5, and the row 2 value is minus 5, so we are going to add up these two rows so that it will be 0. Okay, minus 5 plus 5, 0. But then for the value after the slash, after the line, then you have to plus these two values. So minus 4 plus 9, you will get 5, then plus A. All right, so from here, we know that if A is not minus 5, which means, right, for the last column, last row here, you'll be getting 0x plus 0y plus 0z is not equal to 0 because A is not equal to minus 5. Therefore, 5 plus A, it will not be 0. All right, so when you are getting this, we know that it is impossible because left-hand side already 0, right-hand side is not 0. All right, therefore, we just write hence the system of equations is inconsistent. So inconsistent means that we don't get any solution. Okay. So now interpret this situation geometrically. So the interpretation right will be the three planes form a triangular prism. Okay, because there's no solution for these three equations. Right? So that's all for this question. Now, question 3. The curve C has parametric equations given the x is et minus 1 over 3 t cubed and the y is 4e half t multiplied by t minus 2, whereby the t is from 0 to 2. Now, find in terms of E, the length of C. Okay, so to find the length of C, the formula is integrate 0 to 2, because the t is from 0 to 2, square root of dx dt squared plus dy dt squared, then dt. Okay, this is the formula. Now, first of all, we need to get the dx dt and dy dt expression. So I will do it here. So x is et minus 1 over 3 t cubed. So then dx dt, differentiate et is et, differentiate negative 1 over 3 t cubed, bring out the 3, you will get negative t squared. All right. So now for the y equals to 4e half t bracket t minus 2, when you differentiate, here we need to apply the product rule. So keep the first term and differentiate t minus 2, it will be 1. Then plus, keep the t minus 2, differentiate 4e half t. So it will be 4e half t times half. Okay, so because the differentiate e half t is half. So then you will be getting 4e half t. So the 4 and half will be cancelled off, becomes 2. So I will get 2t minus 2e half t. All right, and then the e half t is in common. So I can just write 4. Then here I do expansion plus 2t minus 4. So at last you'll be getting 2t e half t. This is the dy dx. Then now I will replace all this here. So square root dx dt squared. So et minus t squared, another squared, plus dy dt is 2t e half t. Okay, so now here we have to do expansion because of the square. So when you square of et minus t squared, you will be getting e2t minus 2t squared et plus t degree 4. Okay, and then for the last term, it will be 4t squared et, because e half t squared of e half t is basically e1t dt. Okay, now we may further simplify it before we integrate. So I will rearrange first t degree 4 as the first term. Okay, after that, the second and the fourth term can be simplified. Okay, second and fourth term can be simplified. Then you will get positive 2t squared et and left the e2t at the back. All right, so now you should aware that, see here, square of the minus will be these three terms. And now I'm getting the similar term. It's just that the second term instead of minus has been changed to plus, which means, okay, this is basically square root of et plus t squared. I mean, yeah, square of et plus t squared, because the middle term instead of minus has been changed to plus. So we just change the minus to plus. Okay, so now from here, square and square root can be cancelled off. I will get et plus t squared dt. And now we can easily integrate this. So when you integrate et, it will be et as well. Integrate t squared becomes t cubed over 3. And now replace the t values by 2 and 0. So I will get e squared plus 2 cubed is 8 over 3 minus e0 is 1, then plus 0. Okay, because the t cubed 0 cubed. So therefore, I will be getting e squared plus 8 over 3 minus 1 is basically 5 over 3. So this is the solution for question 3. Okay, length of the C. All right. So now let's move on to the next question. Question 4, which is hyperbolic function questions. So now starting from the definitions of cos and sine in terms of exponentials, prove that cos square x minus sine square x equals to 1. Okay, so we start with cos x. It will be half of ex plus e minus x. And then the sine x is half of ex minus e minus x. All right. So now we prove the left-hand side equals to 1. All right. So now replace. So half ex plus e minus x. This is our cos x. We square it minus half bracket ex minus e minus x, close and square it. Now, we do expansion first. Bring in the square to the half. It becomes 1 over 4. Then you square the summation. Okay, we square this. We have to do expansion now. So it will be e to x plus 2 plus e minus 2x. Okay. Now, for the second term, again, bring in the square to the half. So it becomes 1 over 4. And now the difference is, here is minus, the previous was plus. So, therefore, the expansion will be the same, except the plus 2 change to minus 2. So, e 2x minus 2 plus e negative 2x. Alright, so now from here, you can factorize the 1 over 4, then open all the brackets. So, e 2x plus 2 plus e minus 2x. Bring in the minus. Okay, times in the minus. First term will be minus e 2x. Second term is plus 2. Third term is minus e negative 2x. So now, I will simplify the terms. So, e 2x cancel. Then the e minus 2x also cancel. Okay, so left just 4. 2 plus 2, which is 4. And hence we get 1. So this is how we prove the identity. Alright. So now B, show that differentiation, okay, differentiate inverse tangent sine x with respect to x is hyperbolic second x. Alright, so now we refer to formula d over dx inverse tangent x over a. It will be a over a squared plus x squared. This is the formula. Alright, whereby the a is a constant. So now we need to prove, we need to show d over dx inverse tangent sine x. So I will start with the substitution that u equals to sine x. So du dx will be cos x. Right? So here becomes d over dx inverse tangent u. So when you need to differentiate inverse tangent u with respect to x, it's basically using chain rule. D over du inverse tangent u times du over dx. Alright? So now, inverse tangent u, when you compare with inverse tangent x over a, which means your a is 1 now, because your a is a constant. So I will change the x to 1. So 1 over 1 squared plus u squared times du dx is my cos. Okay? So then you change back. It will be cos x over 1 plus cos square x. Oh, sorry, your u is sine. Okay, 1 plus sine square x. So you are getting this now, but you need to show it is hyperbolic second. So now, second, okay, so hyperbolic second x is basically, hyperbolic second x is 1 over cos x. This is what you need to prove now. Okay, but then since we have the 1 plus sine square x in the denominator, so what we need to do here is we need to change to cos. Right? So refer to this formula, the result from the first part. Cos square x minus sine square x is 1. So now we will write here cos square x minus sine square x is 1. So when I move this minus cos square x to the right side, I will be getting cos square x. Okay, which means here I will get cos x over cos square x. So when you simplify, it will be just 1 over cos. So I will get 1 over cos x which is our hyperbolic second x. So this is how we prove the formula, how we prove the result. Okay, using the inverse tangent formula. Right? So now, C, sketch a graph of y equals to hyperbolic second x, stating the equation of the asymptote. So just for your information, we know that hyperbolic second x is 1 over hyperbolic cos x. Right? So for the cos x, if you still remember, now this is the working, right? This is the guideline. It's not yet the graph. We know that cos, it will be in the same shape of quadratic. All right? It is same shape of quadratic. So this is our y equals to cos x. This is x. Here is 0. Here is y. And now you are sketching hyperbolic second. So our hyperbolic second x, which is this result. Right? Remember, the green color is a reference, but the final answer is the blue color. So now we know that here is 1. Okay. Now, when you replace this point here, when you substitute this point into your hyperbolic second x, so I will get 1 over 1, which is 1 as well. Okay, but since this is minimum point, so 1 over minimum point, it becomes a maximum point. So I will get a maximum point at 0, 1. Instead of minimum in the cos x, now becomes maximum point in the hyperbolic second x. So now, this graph, the original graph, hyperbolic cos x, when the x tends to infinity, the y tends to infinity. So when you consider 1 over infinity, it will tend to 0. Okay? So it will tend to 0. And then we know that the x increasing, when the x increasing, the y increasing. Therefore, 1 over increasing, it will be decreasing. So it means it will be decreased from 1. All right, so I will decrease from 1 and it will tend to 0. So same for the right left-hand side. So when you consider the x value towards negative infinity, the graph increases to infinity, right? So it is the same here. So 1 over increasing, 1 over increasing, it will be decreasing. So from 1, it will decrease to 0. So this is our hyperbolic second x graph. Okay, so that now the graph is done, but don't forget to state the equation of the asymptote. So the equation of the asymptote it will be the x-axis. Okay, because the graph never touches the x-axis when x tends to infinity. So therefore, the x-axis is basically y equals to 0. Alright, so this is how we solve the C. Now D. By considering a suitable set of n rectangles of unit width. Unit width means that it is 1. The width is 1 unit. Use your sketch to show this result or show this inequality. Now, just like we sketch hyperbolic second x, okay? That's why you see here hyperbolic second r. So you can change the r to x later on. Then this is inverse tangent, sine n. So we have proven inverse tangent just now. See here, inverse tangent, sine. So if I need to get this, means that I have to move the d over dx to the right side. And it becomes integration. So now, when you integrate the hyperbolic graph, okay, or the graph, it is representing the area under the curve. Okay, all right. So now I will start with d over dx. Right, because I need to prove this first. So d over dx inverse tangent sine equals to hyperbolic secant x. We have done this just now. So now, inverse tangent hyperbolic sine x, it will be integrate secant x dx. Okay, since we need to use graph, okay, use a sketch. Now, here, we will consider 0 to n. Alright, just this part. So 0 to n, because it's mentioned n sets of rectangles. So 0 to n. Then, now, where I need to solve this, okay, so it will be, differentiate left hand side is right hand side. So if I integrate right hand side, I will get back left hand side. And when I add on the limits, it becomes with limits, the definite integral. So from here, I will rewrite integrate from 0 to n hyperbolic cos secant x dx. So replace the x by n values. So it will be inverse tangent sine n minus inverse tangent sine 0. Okay, so sine 0, it will be 0. So inverse tangent 0 is again 0. So this whole term is basically 0. So then I will be getting just inverse tangent sine n. So I have found this expression. Right. So now, by considering a triple graph, all right, use your sketch to show. So what to do here is we will be using this sketch. Okay. So now, here is 1. This is y, here 0. Use your sketch. This is y equals to hyperbolic secant x. Now, I will add on the rectangles. So, let's say here is the rectangle 1. Then here, rectangle 2. So, please use the ruler to draw the rectangle. This is 3. Okay, so here 1, 2, 3. So, if it is n sets of rectangles, based on the question here, sets of n rectangles, which means, you look at here, this is first rectangle, we will label here 1. Second rectangle, third rectangle. So I will get n rectangle over here. That means this is my n. Okay? So now, from here, we know that the integration is the area under the curve. But then if you consider the rectangles, so obviously the total rectangles here, the total area of the rectangles here is less than the area of the graph. So now, for the area of rectangles, right? So I will say from the graph, total area of n rectangles, which is a summation, second r from 1 to n, is less than the total area under the curve, which is the integration. Okay. Now, here is second 1, second 2. That's why here second r from 1 to n because of n rectangles. So, when you just explain this and together with the graph, so we know that the summation, second r from 1 to n, it will be less than the area of the graph. Okay, so which means it is less than inverse tangent sine n. So this is how we prove this inequality. Okay. Right. So now, hence, state an upper bound in terms of pi for summation second, hyperbolic second r from 1 to infinity. So just now, r from 1 to n. Okay, when you look at here, this is n. Now the n has been changed to infinity. So which means we are taking the limit. So it will be limit n tends to infinity, summation r from 1 to n, hyperbolic second r. And here we know that this is less than limit inverse tangent psi n. Okay, we have proven here. Now, when the n tends to infinity, this one will be less than limit n tends to infinity inverse tangent psi infinity. All right. So psi infinity, it will be infinity. Therefore, I will just direct change to infinity over here. So when you refer to the inverse tangent graph, all right, inverse tangent graph, or we will refer to the tangent graph, it will be easier. Here is 2 pi, this is pi, and this is pi over 2. So we know that tangent graph, this is y equals to tangent x. So we know that from the graph, tangent pi over 2 is infinity, which means pi over 2 is inverse tangent infinity. All right. So that's why this is less than pi over 2. So from here, I will say that my upper bound is pi over 2. Okay. Now, next question, number 5. Find the particular solution of the differential equation 2d squared y over dx squared plus 2dy dx plus y equals to 4x squared plus 3x plus 3. Given that x equals to 0, y equals to dy dx equals to 0, which means all these three are 0. Okay, x equals to x, y, and dy dx equals to 0. So now this is second order differential equation. So firstly, let right side be 0. Then you change to auxiliary equation. Then now this quadratic cannot be factorized. Therefore, we solve using quadratic formula. Minus 2 plus minus square root of b squared, your b is 2, minus 4, a is 2, c is 1. Then over 2a. So at last, you will be getting minus 2 plus minus square root minus 4 over 4. Okay, because of the square root negative, we will be getting the complex roots. All right, so I will get minus half plus minus half I. So 2m values, and they are complex. Okay, so with this m, then you can get the complementary function. So I will write y equals to e minus half x bracket a cos half x plus b sine half x. Okay, so now let me check. Okay, so a lot of spaces. A lot of space is given. So now what to do next is we need to get the particular integral by looking at the right hand side. Since this is a quadratic, therefore I will start with the trial solution of quadratic in terms of PQR. So let y equals to px squared plus qx plus r. And then now we need to differentiate 2 times. So your dy over dx will be 2px plus q. So d squared y over dx squared, it will be 2p. Okay, let all of this be the second equation, and the original function be the first equation. So this is the first equation. So now you substitute, or probably I will copy the equation. So let this be the first equation. Then now, I will substitute second equation into the first equation. So I will get 2 second into first. I will get 2 bracket 2p plus 2 bracket 2px plus q, because that's my dy dx. Then plus px squared plus qx plus r, that equals to 433. So 4x squared plus 3x plus 3. Okay, then now you can just do the expansion for p, 4px plus 2q plus px squared plus qx plus r equals to 4x squared plus 3x plus 3. Now you can compare. Alright, so px squared, 4x squared. So obviously p equals to 4. And then for the q, you may compare the x, right? So you compare the x here. So here is the x, so here is the x. That means I will get 4p plus q. Okay, 4p plus q equals to 3. So now your q will be 3 minus 4p. P is 4. So 3 minus 16, it will be minus 13. After that, you compare the constant. So 4p constant, and then 2q, okay, plus 2q, and then plus r equals to 3 constant. So now from here we need to get the r. So the r is 3 minus 4p, p replaced by 4, and then minus 2q. Alright, so you will get 3 plus 16, then plus 26. Right, 3 minus 16, here is minus. So 3 minus 16 plus 26. So 26 minus 16 is 10, 10 plus 3, 13. So you found the r. Now then, I will write my general solution. Okay, so your y equals to, or probably you can write down the pi first, particular integral. So particular integral, y equals to, just now we let px squared plus qx plus r. So replace it first. So your p is 4, so 4x squared, q is minus 13, then x plus r. Then now general solution, your y is cf plus pi, complementary function. So our complementary function is this, right? E negative half x, a cos, and b sine half x. So now I will write E negative half x, a cos half x plus b sine half x, then plus the pi, 4x squared minus 13x plus 13. So you get this now. And remember, just now you were given the conditions, x, y, and dy dx all are 0. So now we need to replace. So when x equals to 0, so x equals to 0, y equals to 0, because in this equation involves x and y, means that 0 is E0, I get 1. Cos 0, half x, half 0 is 0, so cos 0 is 1. So you get A. B sine 0 is 0. Okay, so we can close the bracket. X is 0, 0, then plus 13. Therefore, your A will be negative 13. So found the A. Now to get the B, you need to differentiate. Okay, differentiate your general solution. So my dy dx. So firstly, when you differentiate, you need to apply the product rule, then followed by the normal differentiation. So product rule means keep the first term, keep the E, differentiate A cos half x, you will get negative half A sine half x. B sine half x is half B cos half x. and then plus, keep the bracket, a cos half x plus b sine half x. Then differentiate exponential negative half x, you will get negative half e negative half x. Okay, plus, now differentiate 4x squared, 8x, differentiate minus 3x, minus 13x, you'll be getting minus 13. Okay, so now to find the b, all right, you let the x be 0 because in this expression it has x and dy dx. And then the dy dx is also 0. Now, left hand side is 0, right hand side is 0, I will get 1. So just ignore it. A sine 0 is 0, so I will be getting half b because b cos 0 is b. Okay, so I will get half b. Then a cos 0 is a, put the a here. B sine 0 is 0. Okay, so close bracket, multiply by negative half because E0 is 1. So 1 times negative half, I will get negative half. And don't forget, minus the plus 8x becomes 0. And then there is another 13 at the back. Right? So now, just now we have found our A is minus 13 here. So we can just substitute directly to get the B. So I will write half B. So this term, I will move to the left side. So I will get half A. My A is negative 13. And then this term also moves to the left side. So it will be plus 13. So now, half times negative 13 plus 13, it will be half of 13. Okay, therefore, the half will be cancelled off from both sides, and your B is 13. So with this B, I will get the final solution. So my Y is just need to rewrite E negative half x, A cos half x. Okay, go back to the general solution. A cos half x, the A is negative 13. So I will get negative 13 cos half x. Plus B, so the B is 13. So B sine half x. After that, plus 4x squared minus 13x plus 13. Okay, so this is the solution for question 5. All right. Okay, so let's move on to question 6. The matrix A is given by A equals to this. All right, find the matrix P and the diagonal matrix D such that A degree 5 is PDP inverse. Okay, so first of all, we need to get the lambda values, right? The eigenvalues and eigenvectors. So we start with the determinant. So determinant of A minus lambda I equals to 0. Let's start with this. So this is your A. So A minus lambda I is basically the diagonal elements you minus lambda. So I will get 2 minus lambda, 0, 0, minus 3, 5 minus lambda, 0, then minus 7, 7, minus 2 minus lambda equals to 0. Okay, since this is the lower triangular matrix, all these are 0. So there's a shortcut. But you need to count this determinant. You just take these 3 diagonal elements. Right, that's a shortcut. So here I will get 2 minus lambda, 5 minus lambda, negative 2 minus lambda, then equals to 0. Okay, that's the shortcut. Now, therefore, I will get my lambda is 2 for the first, then the second is 5, and the third will be minus 2. So we have found the lambda values. Now, with the lambda, you have to get the eigenvector. So when lambda equals to 2, substitute back into the first matrix or first determinant. Now change to matrix. So I will get 2 minus 2, I get 0, 0, 0 for the first column. Second column minus 3. 5 minus 2 is 3. Then 0. Third column minus 7. 7 minus 2 minus 2. I'll get minus 4. Okay, you need to solve this equation. So instead of using square bracket, you can just use normal bracket. Now, you see, when you refer to this, you will notice that the first row and the second row are basically the same, right? Therefore, we will just write one of them. Then I will, of course, start with the last row first. So I will get minus 4z equals to 0. Then my z will be 0. Then 3y plus 7z equals to 0. Then my y is 0. But then we can't find the x. Doesn't mean that the x is 0. Means that your x can be any number. Let it be u. So now I will be getting the first solution. This is u 0, 0. And factorize the u, you'll get 1, 0, 0. So this is my first eigenvector. Corresponds to first eigenvalue. Okay, so now I'll show side by side. So when lambda equals to 5, okay, start with 5 first. Here is 5. Then now, when you recalculate 2 minus 5, I'll get minus 3. Then 0, 0. After that, minus 3. My lambda is 5, so 0, 0. Then when you substitute into the third column, minus 7, 7, minus 2 minus 5, minus 7. Okay, so from here, the second and third row will be the same. So we just take one of them. So maybe I take the third row to form the equation. Then I get my z is 0. So now for the first row, since minus, 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 I can just ignore all the minus and write plus for all. Okay, so now replace the z by 0. I will get x plus y equals to 0. Therefore, my y is minus x. So now my y depends on x. I will let my x be any other unknown. Let it be t. Therefore, my y will be minus t. Okay, so now rewrite the solution. So my x is t, my y is minus t, my z is 0. And here I can factorize the t. So I'll get 1 minus 1, 0. So this is my second eigenvalue. I let it be E2. My E2 will be 1 minus 1, 0. And the corresponding lambda 2 is 5. Okay. Now, solve for lambda equals to minus 2. So, when lambda equals to minus 2, so the first one, 2 minus minus 2, it will be 4. So, first column becomes 4, 0, 0. Okay. Second column, I get 5 minus minus 2. So, for the diagonal element, it will be 7, which means my second column is basically minus 3, 7, 0. So my third column, remember, lambda is minus 2, so this value will be 0. So I will be getting minus 7, 7, 0. Right? So now here, I only get two different equations. So the first one is 7y plus 7z equals to 0. So from here, I can say my z is f. Then my y will be minus f. Okay? So then, first equation, 4x minus 3y minus 7z equals to 0. Replace the z and y by s and minus s to get the x. So I will get 4x equals to 3y plus 7z. So here, minus 3s plus 7s, 4s. Therefore, my s will be s. Alright, so with this, I will just write my x, y, z will be s is x, y is minus s, z is s. So I will factorize all the s. 1 minus 1, 1. So it means that my E3 equals to 1 minus 1, 1, when my lambda 3 is minus 2. So we have found the complete set of eigenvalues with the corresponding eigenvectors. Now, when you look at the question right now, this is not A, it is A degree 5. So basically, if it is A equals to P D P inverse, all right, so this D will be the diagonal matrix that consists of the eigenvalues from the A, and the P will be the matrix that consists of the each column will be the corresponding eigenvectors. But since the degree of A is 5 right now, that means the D here, we need to consider degree of 5. Okay? So now my D is basically degree of 5 for my eigenvalues because of the A degree 5. Okay, and it is a diagonal matrix. So now you can write the first lambda is 2, second is 5, third is minus 2. So it can be in any order. 2 minus 5 minus 2. Then here will be 32, 0, 0, 0, 3, 1, 2, 5. Okay, let me check the, okay, sorry. 2, 5 minus 2. Okay, 2, 5 minus 2. So this is 5, not minus. Then here 0, then 0, 0, negative 32. This will be the matrix D, which is a diagonal matrix. Okay, and the corresponding P will be the corresponding eigenvectors. So each column will be the eigenvectors for the eigenvalue here. So I will just copy 1, 0, 0 when the lambda is 2. So here 1, 0, 0. Then when the lambda is 5, 1 minus 1, 0. So 1 minus 1, 0. And lastly, I will get 1 minus 1, 1. So this will be the solution. Right? Okay, now B, use the characteristic equation of A. Characteristic equation means the determinant of A minus lambda I equals to 0. That is the characteristic equation. To show A degree 4 is A, small a squared plus bi. So the I here is the identity matrix where A and B are integers to be determined. All right. So characteristic equation means the determinant of A minus lambda I equals to 0. So now this is what we have done just now. Okay, remember? Just now we started with this, which means I will be getting this result. Okay, so I will rewrite this. So 2 minus lambda. Then 5 minus lambda minus 2 minus lambda. 5 minus lambda minus 2 minus lambda equals to 0. So now to get the degree 4, we need to do expansion here. So the easier way to do the expansion is if you realize that here is minus 2 minus lambda. Once you factorize a minus, you will get plus negative bracket 2 plus lambda. Then it can be combined with the first using the difference of squares. All right, so I will write 2 minus lambda instead of doing the multiplication, the expansion. I will change to this form first. Then I will be using this formula. A squared minus B squared is A minus B times A plus B. So my A is 2, my B is lambda. So this is A, this is B. So there is a minus outside. This minus I will probably just times into the 5 minus lambda, or you can just leave it outside. It's up to you. Okay, so I will simplify first and third term. It will be 2 square minus lambda square. All right, then this minus I bring into the second bracket. So I will get lambda minus 5. So the 2 square I will change to 4. Okay, then now you further expand it. So 4 lambda minus 20 here minus lambda cube, and this is plus 5 lambda squared equals to 0. So rearrange it, you will get lambda cube plus 5 lambda squared plus 4 lambda minus 20 equals to 0. Okay, now when we need to get the equation in terms of A, so we know that the lambda is actually the eigenvalue from the A, so you can easily change to matrix. Okay, but be careful with the last term, which is 20. This is a constant. So when you change everything to matrix, it should be 20i. I is the identity matrix. All right, so from here, I can get what is my A cube. So my A cube is basically, okay, now I did a mistake here. This is minus lambda cube. So I will move everything to the right side. Okay, I will move everything to the right side. So the lambda cube becomes plus, then the 5 lambda square and 4 lambda will be minus. And then the negative 20 becomes plus. Okay, this should be the correct way. So here, minus, squared, minus, plus. All right, so I get the A cube as a subject. So this is 5a squared plus 4a minus 20i. Now, but then when you look at the question, we need a degree 4 and not a degree 3. So you multiply by a both sides. Okay, so now when you multiply a by both sides, means that you will get a degree 4 equals to 5a cubed plus 4a squared minus 20ia. Okay, when you multiply. So now 20ia is basically a. Now when you look at the question here, we need a squared. Okay, a degree 4 with in terms of a squared and I. But then here we have the a cube and a. Therefore, we need to simplify. So replace this a cube by this result. Okay, this is first, this is second. Substitute first into second because we need to eliminate the a cube and the a. So I will get 5a squared plus 4a minus 20i, which is my a cube, then plus 4a squared, and then other ia becomes a, 20a. Okay, now you do the expansion, it will be 25a squared right? Then here will be plus 20a plus minus 100i plus 4a squared minus 20a. So 25a squared plus 4a squared will be 29a squared. Okay, then 20a minus 20a, 0. Then minus 100i. So when you compare with the given form here, a squared plus bi, which means your a is, small a is 29. Your b, the b here, will be negative 100. So a is 29, b is negative 100. So this is how we solve this question. Okay. Now, question 7. State the sum of the series. Okay, so from here, obviously, this is geometric progression. Okay, or geometric series, I would say GP. So this is GP with A is 1, first term. The common ratio is W. All right. Therefore, summation, or I would say that, yeah, this is summation, R from 0 to n minus 1, which is WR, W degree R, it will be the sum, right? So from here, if you remember, Sn is a bracket Rn minus 1 over R minus 1. So I will write 1. R is W, then N. There are N terms here because here degree 1 are here. N minus 1 means N minus 1 terms. Then plus the first term becomes N terms. Okay, then minus 1 over R minus 1. W minus 1. That means you are getting W power N minus 1 over W minus 1. So this is how we solve 7, 8. Right. Now B. Show that 1 plus I tangent theta, these two terms with degree K is secant theta degree K, bracket cos K theta plus I sin K theta, where the theta is not an integer multiply of pi over 2. Okay, so now you start with the left-hand side. When you look at the right-hand side here, there's no tangent, but you are given sine and cos, which means you have to change the tangent to sine and cos. Okay, and now you get the same denominator. So then I will split into numerator and denominator. So according to the De Moivre's theorem, right, for the numerator, the power k can be brought in. So that's why this 1 plus I tangent theta degree k equals to, now this is cos, see, this is 1 over cos degree k theta. 1 over cos, we know that is secant. That's why this is secant. Okay, so I will get secant degree k. And then for the numerator, this one is based on the De Moivre's theorem. So it will be cos k theta plus I sin k theta. Okay. Now, see, by considering the summation, so now you add on the summation to the left side, show that summation is the same summation. Second power k theta, sin k theta. So here is the second power k. Okay. So you consider the summation of the left-hand side, then equals to right-hand side. So now, let's solve this question. All right. So what I will do here is, firstly, this becomes 1 plus I tangent theta power n minus 1 over 1 plus I tangent theta minus 1. How do I get this basically? Okay, this one is from A. From here. My W, I let my W be this whole bracket. Alright, my R will be the K. Then the sum, instead of R, I change to K. This one here start from K equals to 0, then ends at N minus 1. It's exactly the same. We refer to the part A, and this is the result. This is how I get it. Okay, so now here, okay, so you simplify first. I will get 1 plus I tangent theta to the power of n minus 1 over the denominator, the 1 and minus 1 will be cancelled off. So you are getting I tangent theta. So for this case, now look at the question carefully. We need to prove cotangent. Okay, so because I1 plus I tangent theta is basically secant here. So this is a secant, but you have cos and sine. So later we will consider just the imaginary part. So now, because we need to get the cot here, so I'm not going to times the conjugate for the tangent here, right? The I tangent theta, supposedly the conjugate is minus I tangent theta. So now we need to keep the tangent theta in the denominator. So I times minus I over minus I, the conjugate. So now the minus I is minus I times I, right? Minus I squared, it is minus 1. Therefore, you get 1 here. So now I will get tangent theta. Then the minus I, you can take it out if you want. So you can write minus I here, then 1 plus I tangent theta between n minus 1. Okay, I do it step by step. Then now the tangent theta, I take it out or move up, it becomes cot. So minus I cot theta. All right. So now for this whole part, okay, you need to refer to the part B. So part B here, right? So you see 1 plus I tangent theta power k. So 1 plus I tangent theta power n. So which means the k over there becomes our n. Then you rewrite the minus 1 later on. You just add on. So now I will copy this result and change the k to n because the k already changed to n, right? So I will write second degree n theta, then cos n theta plus I sine n theta, then minus 1. Okay, don't forget there's a minus 1 here. All right, so now we need to do expansion. So here we expand together with the minus cos, minus I cot. I will get minus I cot theta, second degree n theta, cos n theta. Okay, then all this multiply with the I sine n theta. Then now, be careful, I is minus 1. So minus is a plus. That's why I will get plus cot theta, second n theta, then sine n theta. And this cot, the minus I cot theta multiplied by minus 1. So I will get plus I cot theta. Okay, so this is how we get it. Now, but then left hand side is 1 plus I tangent. I need to prove second power k theta sine k theta. Now I'm going to change this. Okay, I'm going to change this by these two terms. Okay, so I will rewrite. Therefore, my summation second power k theta cos k theta plus I sine k theta equals to all these terms. Okay, so k from 0 to n minus 1. So now I notice that first term and third term have I. So have I. That means both are imaginary parts. So I will group these two terms later on. So I will write down. Excuse me. I will write down the real part first. All right. So now the question here needs k sine. So by taking the imaginary part, the summation, second power k sine equals to cot. Okay, this is the imaginary part. All right, so this is how we prove the expression. Okay, so now hence means use the previous answer, find this sum. Okay, so I will rewrite the previous summation. Right, so now when you compare 6m is n, right? So I will write let n equals to 6m, and then sine 1 over 3 k pi. Here sine k theta, which means your theta is 1 over 3 pi. So the left hand side becomes second power k theta. Right hand side cot pi over 3, 1 minus second pi over 3, the n change to 6m cos n theta. So 1 over 3 pi n. Right? So now we know that sine pi over 3 is, okay, wait, not sine. We need to keep the sign. Right, so now here we need to keep the sign. We keep this. So we need to solve the second. So second pi over 3 is 1 over sine pi over 3, which is 1 over half. And then you get 2. So now I will get summation k equals to 0. This is 6m minus 1. This is 2 power k. So 2 power k sine 1 over 3 k pi equals to, okay, the cot pi over 3, you can just use calculator, root 3 over 3. Then 1 minus, okay, again, second pi over 3. Second power 3 is 2. So 2 power 6m. Then cos pi over 3. Okay, now cos pi over 3. So now remember, the n must be replaced by 6m. So here should be 6m. All right, so here I will write 6m. So 6m, 6 and 3 cancel off, you get 2. Right, so now here I should show cos 2m pi. But we know that for the cos graph, this is a cos graph. Here is 1, this is 2 pi. Then here is 1 minus 1. So when you consider the cos graph, right? So cos 2 pi is same as cos 4 pi, same as cos 6 pi, and so on. So it will be 1. That means this is always 1. Okay? So at last, you'll be getting the answer. Right? So this is how we solve D using step-by-step working. Okay, now I think this is the last question. Use the substitution u equals to 1 minus square of theta minus 1 to find this integration. So firstly, copy out the u and get the d theta. So du over d theta. When you differentiate, you'll get negative 2 theta minus 1. So now to get the d theta as a subject, move the d theta up and move down the right side. So negative 1 over 2 bracket theta minus 1 du is d theta. Okay, or I can just keep the d theta minus 1, you see there is a theta minus 1 d theta here. So the theta minus 1 move up. Then that will be better. So I will get negative half du equals to theta minus 1 d theta. Okay, so now for the integration part, probably I'll just sort it on the right side. So now here becomes theta minus 1 d theta is negative half du. So I will write negative half du, negative half du. Then 1 over square root 1 minus, oh, this is just u squared. Okay, so now here negative half integrate 1 over u. There's no squared, okay, mistake. So here will be u degree negative half du. Right, so when you integrate minus half, so here becomes 2u degree half, then plus c, and replace back the u. So negative, the 2.5 cancel, square root the u. Alright, so this is how we solve 8a. Now, for the b, find the solution of the differential equation. This is first order. Given y equals to 1 and theta equals to 1, give your answer in the form y equals to f theta, and it carries 11 marks. So now, first of all, theta dy over d theta minus y equals to theta squared inverse sine theta minus 1. Okay, so since this is first order differential equation, you might consider separable variables or integrating factor, but separable variables doesn't work here. Okay, therefore, we need to apply the integrating factor. So firstly, divide by theta to make the coefficient for dy d theta 1. So here, always plus y, negative 1 over theta, then equals to theta inverse sine theta minus 1. So let this be the first equation. Integrating factor is e integrate negative 1 over theta d theta. That means I will get e negative ln theta. So here e ln theta degree minus 1. At last, you get 1 over theta, which is a theta degree negative 1. This is my second equation. So when you times second into first, by default, the left-hand side will be d over d theta yi, if your I is correct. Then the right-hand side, when you multiply by 1 over theta, you are getting inverse sine theta minus 1. So, y over theta is integrate inverse sine theta minus 1 d theta. So, to integrate inverse sine, we need to apply the integration by parts. Let u equals to inverse sine theta minus 1. Then dv over d theta be 1. This is a 1. So now du over d theta, it will be 1 over square root of 1 square minus theta minus 1 squared. So you can assume the theta minus 1 is a u, because when you differentiate, theta minus 1 is 1. Alright? So then v equals to theta. Okay, so now your y over theta, substitute back into this equation, it will be uv, so theta inverse sine theta minus 1 minus integrate v du. So theta over square root. Okay, so now when you need to integrate the second term here, all right, to compare with the previous step or previous part, we have done integration of theta minus 1 over square root of 1 minus square of theta minus 1. See, here theta minus 1, denominator also theta minus 1. But then, when you refer to here, it's almost the same. It's just that our numerator is theta instead of theta minus 1. So we need to modify our integration, the expression in the integration, so that we can apply the formula from part 1 or part A. So I need to get theta minus 1 from theta, from this theta. So what to do? Rewrite the theta and then add on minus 1 and plus 1. So when minus 1 plus 1, you get 0. Then it will be the same as previous. Then put a bracket for the theta minus 1. Okay, so here you will get theta inverse sine theta minus 1 minus, split it into 2 integrations. Then minus 1 over square root. Right, so here you will get the final answer. This integration you can copy from the previous part, which is negative of square root 1 minus theta minus 1 squared. So negative of square root 1 minus theta minus 1 squared. Okay, then no need to plus c first. Then the right side, the last term, it is basically inverse sine theta minus 1, and then you plus c. So final answer, just simplify the minus, okay, the minus in the second term. All right, so now let's check back the question. Oh, now you are given y equals to 1, theta equals to 1. Then get the y as a subject. All right, so now this is your expression right now. Y is 1, theta is 1. So the y is 1, theta is 1. Left-hand side will be 1. Right-hand side, 1 inverse. So just inverse sine. 1 minus 1, 0. Minus, or minus is plus, square root. 1 minus 1 is 0. Then minus inverse sine, 0 plus c. So inverse sine 0 is 0. Okay, here is 0. This is 0. That means 1 equals to 1 plus c. So our c is 0. Now the question says get the y as a subject. So y equals to f theta. All right. So now you will get y equals to, move the theta to the left hand side, or probably you can just rewrite first, up to you. So it will be theta inverse sine theta minus 1 plus square root 1 minus theta minus 1 squared minus theta outside theta minus 1. Okay, at last, move up the theta. So basically, I can just write y is theta multiplied by all of these terms. Okay, so that's all for the video. I hope you enjoyed this video. All right, so don't forget to subscribe to my channel if you like my videos, and stay tuned for more upcoming videos. Okay, thank you. Bye.